to today's chemistry class. Please do endeavor to like this video and also to subscribe to my channel. Okay, today we'll be looking at the topic Introduction to Mole Concepts. Our end in mind for today's lesson. By the end of this class, you will be able to explain the mole concepts, locate atomic mass of elements in periodic table, calculate molar mass and relative molecular mass, as well as the relative atomic mass of elements. Okay, sit back and enjoy the class. Okay, so now let's look at what a mole is all about. So a mole is a unit of measurements which contain 6.02 times 10 raised to the power 23 particles, as there are 12 grams of atoms in carbon-12 isotopes. Now what this means is just that mole is actually is a unit for us to measure in chemistry. Just like if we have cement, we can say we have 50 kilograms of cement. The kilogram therein is the unit of measurement, when we are looking at weight. Now in chemistry too, we have unit for measurement, and one of the unit for measurement is mole. So I can also liken this mole to a dozen. Now if we say a dozen, we know that a dozen will contain 12 substances. For instance, if I say a dozen of eggs, it simply means there will be 12 eggs in one dozen. So also when we are talking about mole, we can say that a mole contains particles. Now these particles is constant for every element or every element of the periodic table. Now we have the number of particles, which is 6.02 times 10 raised to the power 23. Now this simply means that for every 1 mole, it contains 6.02 times 10 raised to the power 23 particles. Sometimes we use it as molecules or atom. You can say 6.02 times 10 raised to the power 23 molecules. So if we now have 2 moles, it's just for you to multiply by the number of moles, 6.02 times 10 raised to the power 23 times 2. So now this 6.02 times 10 raised to the power 23, we call it Avogadro's number, or what we also call Avogadro's constant. Now if you look at the image here, you can see the image is trying to explain the mole concept. Now in this case, the mole is acting like a scale here, and whereby we have carbon atoms and we have copper atoms. Now if you look at the masses, they have different masses actually. Carbon has 12 while copper has 63.5. But regardless of their masses, they still have the same number of particles, so what we call the same number of atoms, which is 6.02 times 10 raised to the power 23. So that tells you that regardless of the atoms, they will always contain the same number of particles. Magnesium, carbon, copper, calcium, all these elements that we are talking about in the periodic table, regardless of their mass, they will always still have the same number of particles. Okay, so now let's talk about atomic another aspect of the mole. Now when we are talking about the relative atomic mass of an element, we can say the relative atomic mass of an element can be defined as the number of times the average mass of atom of the element is heavier than 1/12 of the mass of one atom of carbon-12. Now this is like a long definition though, but for the sake of examination, it's good for you to be able to state this definition, but it's also good for you to understand the explanation behind this. So what all this is all about, there's something we call isotopes of elements. Isotopes are elements with the same atomic number but different mass number. Now let's look at this. This is the formula for actually to calculate the relative atomic mass of elements. Now how do we arrive at it? Take a look at this. I said something that isotopes are elements with the same atomic number but different mass number. Now we have two isotopes of chlorine, which is chlorine 35 and chlorine 37. Now if you look at the number below, we have 1717. That represents the atomic number. It simply means they have the same atomic number. But now if you look at the number up, we have 35 and we have 37. So this represents the atomic masses. So now what makes these atomic masses different is just because the number of neutrons present in chlorine 35 is different from number of neutrons present in chlorine 37. Please do remember that the atomic masses is made up of protons and neutrons, but atomic number is only made up of the number of protons. So now, since we know that atomic masses is made up of number of protons and number of neutrons, so if we have different number of neutrons, that's what gives rise to the difference in the atomic masses. Now, for us to determine the relative atomic masses, the relative atomic mass of these isotopes is just to find an average of these two isotopes we have here using this formula. Now, there's always something we call the abundance. For instance, chlorine 35 abundance is 75%, while chlorine 37 is 25%. So that tells you how available they are on Earth. So in this case now, we can now say that chlorine 35 is the most abundant isotope. Now, going by this formula, we can say that 75 times this 35, then plus this 25 we have here times 37 divided by 100. So that should give us 35.5 AMU. AMU is actually the unit of measurement of relative atomic mass. So that's how to just go about the calculation of the relative atomic mass. So you can always try to remember this formula, then know how to apply the formula to get your relative atomic masses. So what you will see in periodic table of elements, you will always see the atomic number and the atomic masses of elements. So it's always good for you to be able to know how to identify this atomic number and that of the atomic masses. Okay. Now you can see the periodic table of elements here. So it's just to show you, get you acquainted with the periodic table of elements. Now if you look at this is for oxygen atom. Now the number we have here represents the atomic number, while the number we have here represents the relative atomic mass that we are talking about. So in most cases, except for that of hydrogen, the relative atomic mass is always greater than the atomic number in terms of value. Okay, now look at the second one here. We have chlorine. So this is the atomic mass of chlorine and this is the atomic number. So you should be able to identify atomic number and atomic masses of elements mere looking at it from periodic table of elements. Okay, quickly have this task. Calculate the relative atomic mass of bromine using the information below. Okay, so you are meant to calculate the relative atomic mass of this bromine. We have two bromine isotopes here, bromine 79 and bromine 81. So you can pause this video and solve it, and after you are done, check your answer. So if your answer is 80, give yourself a sound clap. Let's move forward. Relative molecular mass. So what is relative molecular mass? Relative molecular mass, also called the RMM of a substance, is the mass of one molecule of the substance. The relative molecular mass is the sum of the relative atomic mass of all the atoms present in the molecule. The RMM has no unit. Okay, so what that means is that when we are talking about relative molecular mass, it's just like the entire weight of the constituent of a compound. For instance, if I have CO2, I want to know the entire weight of that CO2. Okay, so now let's take this instance. Calculate the relative molecular mass of each of the following: A. H2SO4, B. Aluminium sulfate, then C. Iron sulfate heptahydrate. Okay? Now take a look at this. So we want to calculate for H2SO4. If you look at this now, first you need to determine the number of atoms of each element present in the compound. In this case, we have 2 atoms of hydrogen. Now for this sulfur now, there's no number there, but it's assumed to be 1. So we have 1 atoms of sulfur, but for the oxygen, you can see we have 4. So that tells you we have 4 atoms of oxygen. And all these are represented here. 2 atoms of hydrogen, 1 atom of sulfur, then 4 atoms of oxygen. Now, these 2 atoms, the number of atoms will now be multiplied with the relative atomic masses of each of the elements. So, the relative atomic mass of hydrogen is 1, so we have 2 times 1. The relative atomic mass of sulfur is 32, so that means 1 times 32 will give us 32. The relative atomic mass of oxygen is 16, so that's 4 times 16. That's give us, okay, you can do the calculation, that should be 64 if I'm not mistaken. Okay, now you can then do the mathematics. That's going to be 2 plus 32 plus 64. That gives us 98. So the relative molecular mass of H2SO4 is 98. Okay, I need you to try number the B, which is aluminium sulfate. Please try it and see if you can get the right answer. Pause this video, and after you are done, check the answer below. Okay, so now this is for aluminium sulfate and the iron sulfate. So please go through it. In this case now you see that the aluminium sulfate, the sulfate there, SO4, has a tree. So it simply means this tree you are seeing in SO4 is meant for both sulfur and oxygen. So if we want to look at the number of atoms of sulfur, it's going to be 3. So that means 3 times 1. That gives us the number of sulfur atom. Then for oxygen atom is going to be 3 times 4, which is 12. So it simply means that this tree, it covers all the elements in the brackets. Okay, but for aluminium, it's just 2 atoms. The tree will not affect this aluminium. Okay, so now thereafter we can now multiply the number of atoms with the relative atomic masses. The relative atomic mass of aluminium is 27, so we have 2 times 27. Then for sulfur, it will be 3 times 32, and oxygen 12 times 16. So the rest is calculation. Final answer is 342. So if that's what you got as well, good. If not, try to check it all over again. So you can see that of the iron sulfate too. Okay, that's it for relative molecular mass. Okay, so now let's look at molar mass. Now, talking about molar mass is more or less the same thing like that of the relative molecular mass. In terms of steps for calculation, you follow the same steps to calculate it. The only difference between the relative molecular mass and the molar mass is that molar mass has a unit, and the unit of molar mass is gram per mole, gram per mole. Okay, let's look at what is the meaning of molar mass. The mass of 1 mole of any substance expressed in grams units is called the molar mass. The unit is gram per mole. So that just it. And let's also talk about one or two examples. Calculate molar mass of chlorine gas, Cl2. Now we know that in this chlorine we have 2 atoms of the chlorine. We have 2 atoms of the chlorine here, so that's why we are having these 2. Then the relative atomic mass of chlorine is 35.5. So that's 35.5 times 2. That gives 71 gram per mole. So you will notice that when we calculated for relative molecular mass, we did not put any unit. But when it has to do with molar mass, you must put a unit, which is gram per mole. Okay, and try to calculate molar mass for carbon dioxide gas, which is CO2. The relative atomic mass of carbon is 12 and oxygen is 16. So try to do that quickly. Okay, you can check the answer once you are done. So that's it, 44 gram per mole. So if you didn't get this, try to check your step again and see where you missed it. So that will be all for today. Thank you. Please do remember to like this video and subscribe to the channel. Thank you. See you some other time.